Okay, I'm going to do the last two problems of this review. We are on this one here. This one, this quadratic is going to open up. I know that because our A is positive. To find the vertex, we're going to say x equals negative b over 2a. The opposite of b, basically. The opposite, when I plug that in, it's going to become a positive 8 over 2 times 1. So I have 8 divided by 2, which is 4. Again, whenever we know an x to find a y, you just plug it into the problem. So you're going to say 4 squared minus 8 times 4 plus 8. 16 minus 32 is a negative 16 plus 8. I think it gives us a negative 8, but you don't have to know that. You can just do this on your calculator. Use your store button. Get out of that. I'm going to use my store button, so I'm going to say 4 store x. And I'm going to plug in x squared minus 8x plus 8. And it does give me a negative 8. So our vertex is 4, negative 8. I was trying to make that negative 8 better, but it didn't seem to get that way. Okay, so if you want, you can go ahead and go 4, negative 8. Looks like about right there. Okay. Now, to find the x-intercepts, as always, you plug 0, set y equal to 0. I don't like it written there, so I'm going to write it over here. So I have 0 equals x squared minus 8x plus 8. That does not factor. You can do this one of two ways. You can't do square root property because we have a bx, we have a b, so that won't work. You can do quadratic formula if you want, or you can complete the square. Either way, it doesn't really matter. If you complete the square, you got to take the 8 to the other side, and you'd have x squared minus 8x, leave some room, and when you move this over to here, it becomes negative 8. Well, take half of the 8, negative 8, which is negative 4, then you square it and you get 16. Okay, then on this side of the equal sign, you have 8. On this side, you're going to factor that, and it factors as x minus 4 times x minus 4, so we write it like this. Now we use the square root property. That cancels, and we have x minus 4 equals, this is not a perfect square, so we're going to end up with two irrational answers. I know that because I can't take square root of 8. So you're going to have two irrational solutions or answers. Either way, it doesn't matter. I've kind of gone back and forth between the two of them. This can be simplified because I can rewrite this as 4 times 2 under there. So the square root of 4 gives me 2. So this is plus or minus 2 times the square root of 2. Now all I do is add 4. And I have x is equal to 4 plus or minus 2 times the square root of 2. Now, this is actually the point for plus 2 square roots of 2, comma 0, and for minus 2 square root of 2, comma 0. And I can show you how to use that even to check your answer. Okay, that's one way to do it. This is completing the square. The second way is quadratic. X equals negative b, so we get 8 plus or minus the square root of b squared minus 4 times our a, which is 1, times our 8, c, which is 8, all over 2 times our a, which is 1. So on the top we have 8 plus or minus. When we do this, we're going to end up with 64 minus 32, and we get 32. Again, 32 is not a perfect square. The discriminant is this number right here, okay? So our discriminant is 32 divided by 2. So we now, this I can rewrite that as 2 times 16. Okay, that can be written as 2 times 16 under there. So we get 8 plus or minus 4 times the square root of 2 all over 2. This reduces by 2. Okay, I'm running out of room. Let me put it over here. 2 goes into 8 4 times. 2 goes into this 2 times. And 2 goes into that 1 time. So I ended up with the exact same thing that I ended up with here. It does not matter. Okay? So the y-intercept, and I'll graph these in just a minute. Okay? The y-intercept is just 8. So it's 0, 8. Because again, you plug 0 in for x. You set x equal to 0. So that becomes 0 minus 0 plus 8 gives us 8. Alright. So, and I already know my axis of symmetry is going to be x equals 4 because it matches our x value up here on our vertex. Okay, so now 0, 8, 0 up 8 is right here. That's the y-intercept. Now these I have to do some work. I have to say 4 plus square root, oops, no, wait, 2, let's try this again. 4 plus 2 times the square root of 2. This one here is 6.8 comma 0. And then the minus, oh, yeah, that's right. I was thinking I had to divide by something. And that is 1.2. Okay, comma 0. Because again, we're just rounding it so that, because we can't tell exactly where that is. 6.8 is between 6 and 7, but it's closer to 7, so it's going to be about right in there. 1.2 is between 1 and 2, but it's closer to 1, so it's about right there. Now, we have this axis of symmetry right through here. And because of that, by the way, that's at x is equal to 4. Okay, sorry. I thought I'd put 1 down here. That's why I was like, what? Okay, I don't like that line. It's a little too thick. Probably ain't going to be any better, but oh well. Okay, because of this point here, 1, 2, 3, 4, it's going to be the same distance over here. 1, 2, 3, 4. So there we have another point just because we know about the symmetry. Okay, kind of like here. This is the same distance as that. So these two are the same distance. So now it just gives us another point to connect. Remember again, it's not a V. And it doesn't have to be perfect. Okay, mine is not. Alright, it kind of curves there. Okay, let's check our graph. Let's change this. It's x squared minus 8x plus 8. I just changed what I had in there. It should be in Zoom 6, so let's just keep it. If it doesn't look right, I can just hit Zoom 6 at any time. Well, it does open up just like ours does. Let's check our vertex. Well, actually, if we hit trace, it comes up 0, 8 on our y-axis. But even if you didn't do that, it's not that big a deal. Let's find our vertex. This is a minimum. Second, trace minimum 3. It is on the left bound, so I can hit enter. You can hit it anywhere, okay. It's on the right bound, hit enter. Put it in the middle, 4, -8, and that's what we have right here. Now, at this point, I can actually check this, okay, or this, whichever, it's the same thing. Let's try that. I can actually, remember, if I wanted to know what the y-intercept is, that means x is 0. So I just type in 0 and hit enter, and it gives me 8. Well, I can do the same thing by just checking this and saying 4 plus 2 times the square root of 2. And if that is, in fact, an x-intercept, when I hit enter, my y will be 0. And it is. And I could do the same thing with 4 minus 2 times the square root of 2. And it gives us 0. Okay? So, or you can, now the only thing is if you go to do this, that's to know if this is the answer, if that's the kind of answer they give you. Okay? You can check it that way. If they give you decimal answers, well, then you can just do second calc. 0, number 2, and you can put this on the left side of that. Okay, so I'm going to use my left arrow key. It is now to the left of my pen. Okay, I'm going to hit enter. Now go down below, hit enter, and you'll notice that the 2 lines, let's see if I can, there we go. See the 2 lines? Barely. That is between it. Okay, and now all I have to do is hit enter. And it gives me that 1.2, and that's what I had here. And now, let me see if I can, okay, second calc, and I'm going to do this one. Let's try it again, second calc, 2. Put it on the left bound. It is to the left of that spot, so I'm going to hit enter. Put it somewhere on the right-hand side. That's going to be above it. Hit enter, and notice this is between these 2 lines. I'm just going to hit enter again, and it gives me 6.8. So I know it's right. Now, again, if I wanted to know this here, all I had to do is hit 0, and it gives us that. Okay. And the last problem. Okay, the last problem reads this. Now, I'm going to do this backwards. I'm going to find it on my calculator first. Yeah, let's do it. Alright, it doesn't really matter because I'm going to show it both ways. Negative x squared plus 2x minus 3. Graph, it's going to open down because of that negative. Oh, look, we do not have any x-intercepts. As long as I graphed it correctly, which it is, I mean I've plugged it in right, I have no x-intercepts. Now I got to show you what's going to happen over here in that case. Okay, so I do have a y-intercept. All I have to do is hit trace, and that's going to be at 0, -3. You did not need your calculator to know that. It's that number right there, because this, when you plug in 0 here, you get 0. When you plug in 0 there, you get 0, so it's end up with a -3. Now, your vertex, second calc, that is a maximum because we have a hill. It is on the left-hand side. I'm going to hit enter. Put it over to the right-hand side. Hit enter. And then hit enter. Now, you can't see these lines where it's at, but and I'm leaving it here because you see these 2 arrows? That hill is in between those 2 arrows. The older calculators don't have those little lines. They just have the arrows. But it's okay. Well, I'm lucky in the fact that mine has the lines. So, hit enter, and it looks like it's going to be at 1, -2. Okay, so 1, -2. But let's double check that. And then there are none here. There are no x-intercepts. Okay, now that means we have an axis of symmetry at x equals 1. I know that because it's got to go through there. Okay, let's do this by hand. X equals negative b over 2a. I promise if you do this every single time you work problems and not just watch me, you actually do the problems, you will get much better at them and you will know this formula. So it's going to be negative 2 over 2 times a negative 1. That's going to be negative 2 over negative 2. So we get a positive 1. Okay, negative 2 divided by negative 2 gives us positive 1. Now, anytime we know the x value, to find the y value, you plug it in. Negative 1 squared plus 2 times 1 minus 3. Negative 1 plus 2 gives me 1, minus 3 gives me a negative 2. Okay, but you need to be able to make sure you know how to do this on your calculator. I'm going to stress, use your store button. Whoops, I was pounding on my desk and I have this thing on my computer that helps you see the calculator because it shadows, it kind of protects it from the light above me. Okay, use your store button. 1 store x, and then you're going to say negative x squared plus 2x minus 3, and it gives you negative 2. Because look at what I did. X is just 1, not negative 1. And sometimes people will put this negative inside that parenthesis, but it's not. This is like saying negative 1 times x to the second power. So it'd be negative 1 times 1 to the second power, which is negative 1. Okay, now I want to show you the x-intercepts. This one will not factor. Okay, it will not factor. So chances are you're going to use quadratic formula. So it doesn't really matter if you use that or completing the square. So we got negative b, so it's going to be negative 2 plus or minus the square root of our b squared, which is 2 squared, minus 4 times negative 1 times negative 3, all over 2 times our a, which is negative 1. Okay, our discriminant. The discriminant is what's underneath that radical. Okay, so I'm just going to talk about that again. Discriminant, because you are going to need this for your final. The discriminant is the number that's under the radical, not the square root of that number. Okay, so when you do this problem, you're going to get negative 8 underneath there. Okay, let me just double check that. 2 squared minus 4 times negative 1 times negative 3, and we get negative 8. So the discriminant is negative 8. Okay, that tells me that I'm going to have 2 imaginary solutions, or complex solutions. Complex just means it's a real part and a imaginary part. So really it's complex, but it doesn't really matter on that. Okay, all right, so we really have this problem right here. Negative 2 plus or minus the square root of a negative 8 all over negative 2. All right, now if we were to simplify this out, okay, if we were going to finish this out, if it's just a solving problem, under here I'd had negative 1 times 4 times 2. Okay, so when I simplify this, I'm going to have negative 2 plus or minus, this gives me I, this gives me 2. So I have 2 I times the square root of 2 all over a negative 2. And when I finish that out, I'm going to divide this by a negative 2 and I get a positive 1. This I divide by negative 2. What I'm doing is dividing everything by negative 2. Okay? And I get plus or minus I times the square root of 2. Okay? Now, imaginary numbers do not show up on a graph. Okay? So these will not show up as x-intercepts. And that's why we don't have any x-intercepts. Okay? So, what numbers are we going to graph? All right, 1, negative 2, it's right here. And we had 0, negative 3. And then we've got this vertex coming through right here. I mean, sorry, not a vertex. Axis of symmetry coming through the vertex at x equals 1. Okay, again, it's an imaginary line. So, if you don't have any other points in this, you'll miss this, all right? But we don't have to do any more work. We have another point. Because of that axis of symmetry, we've got one over here on the right. Now you can draw your points. Now, if you want more points than just that, and you have your graph, let's do it right here. Okay. There we go. If I hit trace, okay, it's up there. Doesn't really matter. Let's say I wanted to know at 3. We have one at 2 right there. Where would that point be if 3? Now you can take 3 and plug it in here, but all you have to do, your calculator will do that work for you. 3, negative 6. So I could go 3, negative 6 right here. Well, if I have a point right there, which is 2 to the right, I've got one that's 2 to the left. And just to check that, that's at a negative 1. So a negative 1, I get negative 6. Or you could hit second table, and you got all kinds of graphs here. Points. All kinds of points you can use. There's your 3, negative 6. There was your negative 1. Oops. Try this one, negative 1, negative 6. If you wanted one at negative 2, you'd go down to 11. All right? Notice you'd have 4 down 11. There, because they're symmetric. So now, again, you really don't have to have the extra points. Okay? Don't like that. You know, you really just need these 3 for now in this class. If you were in my other class, I probably would have you do the other 2 points as well, because you really like 5 points. We like 5 points, but it's okay for now. Okay, that finishes up the review.